Is a puzzle. Two friends H and K are playing a game. There are 346 coins, and each of them take turns to pick up some coins. They can pick either 2 or 3 or 4 or 5 coins in each turn, and whichever person picks up the last coin, he wins the game. If only one coin is left on the table, then that player is allowed last coin. The person is allowed to pick up that coin. In all other cases, only 2 or 3 or 4 or 5 coins are allowed to be picked up. Now, if the game starts and H is starting to play the game, and H is picking up 3 coins out of the 346 total coins. Who will win the game and who will lose the game? This is the question. To understand this problem, we need to see that a person can pick up either 2 or 3 or 4 or 5 coins in normal scenario. Only when there is a last one coin, he is allowed to pick up that coin. In all other scenarios, he is allowed to pick up 2 or 3 or 4 or 5 coins. Now let us look at various cases and see in what all cases the first person who is starting will win the game, and in what all cases the first person who is starting the game will lose the game. Now let us assume H is starting the game. H starts the game and we'll also assume that we'll take case 1. In case 1 there are only one coin on the table. If there is only one coin on the table, H is allowed to pick up that one coin, and in this case H wins the game. Okay. And in case 2, let's assume there are 2 coins on the table. If there are 2 coins on the table, H is allowed to pick 2 coins. H is allowed to pick 3, 4, 5. So in all the cases from case 2 to case 5, where there are 2 coins, 3 coins, 4 coins and 5 coins on the table, H is allowed to pick that many number of coins, and being the last person who picks up the coins, H will win the game. So from this we can see that if there are 1 coin or 2 coins or 3 coins, 4 coins and 5 coins, this is what we will call as winning position. So whichever guy is playing this particular position, he will definitely win the game. Okay. Now let's see what happens in the next scenario. Next scenario is like case 6, where there are 6 coins in the table. So now what happens is whatever coin H picks up, let's assume H is there are 6 coins on the table and H is starting right now. Whatever coin H picks up, it will push the opposite person to the winning position. If H picks up 2 coins, the opposite person will have 4 coins to pick, and 4 coin is a winning position. That guy will take all 4 coins and he will win the game. If H picks 3 coins, the opposite person can pick up the remaining 3 coins and the opposite person will win the game. If H picks up 4 coins, the opposite person can pick up the remaining 3 coins and the opposite person will win the game. If H picks up 5 coins, the opposite person can pick up 1 coin, the last 1 coin from the table, and the opposite person will win the game. In which case, the person who is starting with 6 coins will lose. So, the 6 coin position is a losing position. What about 7 coin position? Very similar. Case 7, where there are 7 coins. I am allowed to pick 2 coins. If I pick 2 coins, my opponent can pick up how many coins? 5 coins, my opponent will win the game. If I pick up 3 coins, my opponent can pick up 4 coins, my opponent will win the game. If I pick up 4 coins, my opponent can pick up 3 coins, my opponent will win the game. If I pick up 5 coins and the opponent can pick up 2 coins, the opponent will only win in all these cases. Once again, this is a losing position for me. So one thing I can see here is number 6 and number 7, these are losing positions for me. Now it is my objective to make sure that I push my opponent to the losing positions, and wherever it is possible I need to move to winning position. Now you know what happens in case 8. In case 8, when there are 8 coins, I have a choice to pick up 2 or 3 or 4 or 5. I have a choice to pick up 2 or 3 or 4 or 5, but I am playing this game brilliantly, so I will not pick up 5 or 4 or 3 coins. Because if I pick 5 or 4 or 3 coins, my opponent will have 3 or 4 or 5 coins, and my opponent will go to the winning position, which I don't want. So what I will do is, I have a choice to pick up either 2 or 3 or 4 or 5. No, I will not pick up 3 or 4 or 5. Rather, I will pick up 2 coins. The reason I will pick up 2 coins is that will push my opponent to 6th position, which is as we have seen, 6th position is a losing position. So opponent will lose and I will win the game. So similarly, if there are 9 coins on the table, I will pick up either 2 coins or 3 coins. I can pick up 2 coins, that will push my opponent to 7 position, which is a losing position, or I will pick up 3 coins, that will push my opponent to 6, which is a losing position, and I will win in both the scenarios. What happens if there are 10 coins on the table? If there are 10 coins on the table, I still have multiple choice. I can either pick 3 coins and I will push my opponent to 7 position, which is a losing position for the opposition, or I will pick 4 coins and I will push the opposition to, my opponent will move to 6 coin position and he will be in losing position, in which case I will win the game. And the same thing will continue for 11 coin scenario also. In 11 coin scenario also, what will happen is I have a choice to pick either 4 coins, which will push my opposition to 7 coin scenario, in which case that's a losing position, or I can pick up 5 coins and that will push my opposition to a 6 position scenario, which is a losing position, in which scenario I will win. So these two scenarios I will win. What if I have 12 coins? If I have 12 coins, there's only one thing that I can do. I have to pick up 5 coins. If I pick up anything else, I will not be in a winning position. I will push my opponent to winning position. I have to pick up 5 coins. Only then I will push my opposition to 7, and that will my 7 is a losing position for my opponent. Therefore, I will win the game. So 8, 9, 10, 11, 12. These scenarios are actually winning scenarios. Now, what happens if there are 13 coins on the table? If there are 13 coins on the table, and if I have to pick up whatever coin I pick up, I will put my opponent to a winning position. Because if I pick up 2 coins, my opponent will have 11 coins, and 11 coins is a winning position. That's just now we saw. If I pick up 3 coins, my opponent will have 10 coins. 10 is a winning position. If I pick up 4 coins, my opponent will have 9 coins, and that is a winning position. If I pick up 5 coins, my opponent will have 8 coins, and 8 coin is a winning position scenario, and therefore 13, whatever I do, my opponent will win. So 13 is a losing position for me. What about 14 here? If I pick up 14, I mean, if there are 14 coins on the table, and let's say if I pick up 2 coins, I push my opponent to 12 coins, which is a winning position. If I pick up 3 coins, I push my opponent to 11 coin scenario, which is a winning position. If I pick up 4 coins, I push my opponent to 10 position, which is a winning position. If I pick up 5 coins, I push my opponent to 9 coins position, which is another winning position. Therefore, whatever choice I take here, it is a losing position for me. Okay, so I can see the pattern here. For first 5 positions, it's a winning position. The next 2 positions, it's a losing position. The next 5 positions, it's a winning position. The next 2 positions, it's a losing position. So going by this pattern, your guess would be, so does that mean that 15 coin position is a winning position? Absolutely yes. Because if I get 15 coins, I will brilliantly pick 2 coins, and then I will make my opponent be in a situation where he's forced to pick 13 coins, and 13 coins is a losing position. Therefore, if I have to summarize this game, I can see that 1, 2, 3, 4, 5, these are winning position. 6 and 7 are losing position. Once again, 8, 9, 10, 11, 12, these are winning position. 13 and 14 are losing position. So, and this pattern keeps on repeating. 15, 16, 17, 18, 19 are winning position. 20, 21 are losing position. And how many coins are there in total? In total there are 346 coins. Yeah, so 346 coins. So if I keep on multiplying, as you can see, that's a 7 cycle. So until 343 they'll be on cycle, and then 344, 345 and 346 will be there. So now if H is starting this game here, H from here, he is picking up 3 coins. So H is in winning position. So when the moment H picks 3 coins, that pushes K to 343 coins. Now whatever coin K picks up right now, H will be, so if K picks up 2 coins, H will be in, let's say this is 342, this is 341, this is 340, this is 339, 338 and 337. Whatever coin K picks up, if K picks up 2 coins, that will put H here. If K picks up 3 coins, that will put H here. If K picks up 4 coins, that will put H here. If K picks up 5 coins, that will put H here. So whatever coin K picks up, that will put H in the winning position once again. So this is winning position, this is a losing position. So whatever coin K picks up, that will put H into this position. And now once again H will make sure that K stays in the losing position again and again and again, all the way until last scenario. So here once again K will be pushed into losing position. Whatever coin he picks up, H will pick up the entire of the remaining coin, and H will win the game. And H will win the game, and K will lose the game. And therefore if the so they, let's say if there are 346 coins and H starts the game, the objective of H is to make sure that K is pushed into losing position. So K will have to take, H will have to take how many coins? Either 3 coins or 4 coins. Only if H takes 3 or 4 coins, that will push K to the losing position. So and H will make sure that he plays game in such a way that he keeps K in the losing position in every round. I'll give you another example where, let's say H is having, let's say 19 coins. Now what is the number of coins that H should take so as to make K lose? If H takes 2 coins, K will be in winning position. If H takes 3 coins, K will be in winning position. If H takes 4 coins, K will be in winning position. H2 should take 5 coins, correct. Only if H takes 5 coins, it will push K to losing position. Losing position means whatever K does right now, K will remaining in losing position. If K takes 2 coins, H will have 12 coins. K takes 3 coins, H will have 11. K takes 4 coins, H will have 10. If K takes 5 coins, H will take 9. So whatever decision K does, it will put our H once again in winning position. And from here, our H will control the game such that K stays once again in the losing position. So anybody who is having the coins in this region, they will win the game. Anybody who is having coins in this region, they will lose the game. And since 346 lies here, and H brilliantly takes 3 coins and pushes K to the losing position, and if these two people continue to play brilliantly, H will win the game and K will lose the game.